Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic will be database foundations in NoSQL. So let's first start off by talking about what is a NoSQL database. Okay, and a NoSQL database in a nutshell is a database that allows the insertion of data without a predefined schema. Okay, and schema is just kind of like the model, the shape of the data, right? So that is the type of database we're going to be learning about. Now, there's many different varieties of providers of NoSQL database, okay? But one of the most popular and most efficient is MongoDB, okay? And so we're going to be using MongoDB for our NoSQL solution. And then we're going to be using a tool called MLab to store all of our data in the cloud, and so that way we don't have to store it on our local machine. Okay. So the first thing we need to do is, if you don't already have an MLab account, you need to go to mlab.com and sign up for free. And then it's going to bring you to this menu here, and we'll create a new database. Okay, so from here, I'm going to choose AWS as my cloud provider and free for the plan type, and continue. So next, we just need to choose the region nearest us and continue. And then I'll give it a database name. I'll call it our super database. Okay, so now we verify everything's correct, and just give a minute to initialize the database there. Okay, and next we can go ahead and discuss the various inner workings of this database. Okay, so first you might notice this tab called collections. Okay, and what collections are inside of a MongoDB database are they're different groups of data. So you can imagine, like on a website like Facebook, for example, you're going to have like user data, and then you're going to have like post data, right, for different posts like images and pictures and videos and stuff like that. Okay, but they won't all be stored in the same place in the database. They'll be stored in different categories. And so this is what collections are, okay? And within each collection, there's individual records referred to as documents. And each document is represented in like a JSON-like format. So you can refer to each of the corresponding key values as fields, okay? And each field has a value on that document. So now we discussed the anatomy of a MongoDB database. Let's go ahead and talk about the authentication factor, okay? So with a regular setup, normally the company would be maybe the account user, and then you would have authenticated users in the company that could access the database. So let's go and add one of those. Let's call him Isaac, and password 123. Okay. So now I've added a database user. What that allows me to do is it allows me to connect to what's called the Mongo shell. Okay, and the Mongo shell will be installed whenever you install MongoDB. It'll come as part of that installation. Okay, so make sure you got that installed, and then that's going to allow us to connect to this cloud database here. Okay, so these other tabs here, you might notice stats, right? Just records actions and operations in our database. Backups for, instances where our data gets wiped out, right? We can have actual backups for that. And then they just got third-party import, export tools, as, you'll need those for, studying your data and running different analysis on it. Okay, so now we have an idea how to navigate around MLab now. Let's go ahead and let's connect to this database by first copying this link here. Okay, let's go to our command line. Let's go ahead and let's start off by pasting that in. But before I hit enter, I'm just going to come back here and change out this database user because it's just a placeholder. So I need to say database user is Isaac, and we need the password was 123. Okay, so now if I hit enter, using my Mongo shell, it's now connected from my local machine to that database in the cloud, okay? So now I don't have to worry about storing data on my computer and then my computer getting, coffee spilled on it or something, right? There goes all my data, right? That would be crazy. So now we have a way to perform different operations and interact with our database, okay? And the four most common operations you're going to be performing with any database are referred to as CRUD, okay? And CRUD stands for create, read, update, and delete, okay? So let's go ahead and let's learn how we can use our Mongo shell here to perform those different operations. So first things first, in our database, we're going to need some collections to work with, okay? So let's just say we want to add some cars to our database. We'll have a car database. So I'm just going to call this collection cars. By convention, they're always, plural, not singular, because they should indicate many. As you can see at this time, we have 0 documents, right? So to add a document, we simply need to say DB, and then we reference the specific collection. And in this case, the collection is cars. So we're going to say db.cars, then we're going to say insert 1. And we just have to enter like a key value pair, right? It's like an object we're passing in. So what I can do from here is I'll simply give the car a type. Okay, let's call it Tesla. And let's give it a year. And let's say it's 2017. Okay, as you can see, it acknowledged true, and it assigned it a unique ID. Okay, so this is one of the awesome parts about MongoDB is it'll automatically generate IDs for each document. So even if 2 documents have like maybe the same type, right? Maybe they're both type Tesla, you could differentiate them still because they have a unique ID. So if we come to our database now and we refresh, we can see that in the cars collection, we have 1 document. Okay, and that document has the type and year, just how we entered it. And then it's assigned this unique ID here, okay? So let's aggregate a bit more data so we can, play with it a little more. So I'm just going to add a couple more cars here. So the next one, let's go ahead and make this one a type equal to, let's do Mercedes. Okay, and for the year on the Mercedes, let's do 2000. Okay. As you can see, that was successful. So let's add just one more car here, just get the hang of it. Say insert 1, type, we'll say BMW for this, and year, let's say 2006. Okay. So now we can head back to our database and we refresh. We can see that we've added all these different documents, right? 3 different cars with different years and types. So we now know how to create data, right? Now, so let's go ahead and move on to the next operation of CRUD, which is reading that data. Okay, so if we just wanted to say read all given documents in a certain collection, say cars, we could do the following command. We could say db.cars.find. Okay, and then we're just going to pass in an empty filter here, and that's just going to retrieve all. But if we wanted to, we could pass in specific things like equality, right, and just certain other conditions. But for now, we just want all cars. Okay, so we'll say db.cars.find. Okay, and as you can see, it just returns all documents in that collection. Okay, but as you can imagine, we're going to go on and get a little more fine-grained than that as far as our control goes when we run these queries, because we're not just going to want all data from all collections all the time. So most of the time, we're going to want actually just very specific items within collections. Okay, so next, let's go ahead and let's learn how we can query documents by equality. When I mean equality, I mean, for instance, look up all cars with a type of Tesla, okay? With a type is equal to Tesla, right? Equality. So I'm going to go ahead and say db.cars.find, okay? And then I'm going to go ahead and pass in the type here. And we'll pass in the equal operator. And this is going to be equal to Tesla. Okay, so we go ahead and close that up. And as you can see, it only returns one document, right? That's the document whose type was equal to Tesla. So we know that worked. Okay, so now let's go ahead and explore, well, how can we query documents by maybe a comparison value, right? So maybe all cars that are greater than the year 2005. Okay, so to do this, we would say db.cars.find. Then we would say year, and we pass in the greater than operand, and we would say 2005. Okay. As you can see, it only returns two cars, right? Car with the year 2006 and 2017. And it leaves that car with the year 2000 out because that does not evaluate to true. Okay, so we know that that query is working. So next, let's go ahead and flip-flop that, and let's try to find all cars less than the year 2005. So let's say db.cars.find, and we'll query the year with the less than operand. We'll say 2005. And as we can see right here, we're getting only one car now, and that's the car with the year 2000. So moving right along, let's go ahead and now let's go ahead and discuss how we can look up cars using logical operators such as and or statements. Okay, so let's start off by saying we want to find all cars that are less than let's say 2010 and greater than 2005. So to do this, we would say db.cars.find, and then we would pass in the and brand with a parentheses or a array that will hold multiple values, right? So from here, I'm going to pass in the first expression, which is find the cars whose year is greater than, we will say 2000, well, let's start with less than, actually, less than 2010. Okay, and then second expression here will be for the year it's greater than 2005. Okay, and we can see from this query only one document got returned. That was the car with the year 2006 because it's greater than 2005 and it's less than 2010. Everything else was not, so those documents were not returned. So we know that that query is working. So now let's go ahead and let's explore the or statement, right? How can we use that just like we use and? Okay, so let's say we're looking for Teslas or BMWs, right? And we don't care, we just want one or the other. So how we can run that query is we could say db.cars.find, and we'll start off by saying or, put an array with my conditions, right? So I'm going to say type equal to Tesla, or type equal to BMW. Okay, so we'll close the array there. Okay, so as we can see, now it returns only two cars, right? The car with type of Tesla and BMW, right? And it did not return anything else because it was just matching these two types, or, right? One or the other. So Let's go ahead and let's take a moment to open up the floor. Let's see if anyone has any questions over what we've been over so far. Okay, so the floor is open. If you have questions, feel free to ask them now. Okay, so if there's no questions, let's go ahead and move forward. So next, let's talk about a specific topic called a projection. Okay, so projection is a query where we only ask for the parts of the document we need and nothing else. Okay, and this is much more proficient and much more performant. So let's say, for example, we only need the title of a car. We don't need anything else about it. So if that's the case, I can say db.cars.find, okay, and I'm going to find the car with type equal to Tesla. Okay, and then to set the projection, I'm simply going to pass in the field of the document I want. So in my case, I only want the type, okay, and I'll pass in 1 for true. Okay, if I pass in 0, that would mean false. So let's go ahead and let's execute that. Okay, and as you can see, now it's only returned the type, and by default we get the ID back, but we're not getting the year anymore, right? So if we wanted to, we could even request, and make sure that it doesn't give us the ID either by just using a 0 for the ID, right? So I could say db.cars.find, and we'll find cars with type Tesla. Okay, the projection would be underscore ID, and that's going to be 0. Okay, and then we want to make sure it uses the type. So we'll say type equals 1. Okay, so looks good there. Let's go and close that off. Okay, and as you can see now, using this projection, I'm only getting the bare necessary information I need. I didn't have to do a big heavy query, and wait for a big heavy document to get back to me. I only retrieve the bits and pieces I needed. Okay, so this is considered much more performant and very good best practice. So moving on from projections, let's go ahead and let's just move on from queries altogether. We've covered a good amount of ground on how we can insert and create data in our database, and also a good amount of ground on how we can read documents in various different ways. So now let's go ahead and let's explore how we can update and delete those documents. So let's start with update. Okay, so let's say the year is changing, so we want to change Tesla from 2017 to 2018. So how I could do this is I could say db.cars.update 1. Okay, with the type is equal to Tesla. Okay, and then we'll use the bling set operator. Okay, and we'll set the value of the year to the year 2018. Okay, and as you can see, it acknowledged as successful. So now let's go ahead and go to our database and we refresh. We can see that's gone from 2017 to 2018, right? So we're successfully updating data in our database now. Okay, so moving right along, let's go ahead and talk about deleting that data, okay? So what I'm gonna do is maybe let's delete all cars with the type of BMW. So to do this, we could say db.cars.remove type BMW. Okay, so we got this confirmation message here. So now we can come back and we refresh. We can see that all the cars of the type of BMW have been removed. So we've successfully just completed full CRUD operations, right? We can create, read, update, and delete data, using our Mongo shell here to interact with our database. So that being said, let's go ahead and let's move on to the concept of indexes. Okay, so in a database, best to use as many optimizations as possible, and index is considered one of those optimizations. Okay, so an index is basically just an ordered copy of a document or a specific field that you query quite often. Okay, so if we come back to our documents here, we can see that we have built-in indexes for ID, right? Because ID is a field that's queried very, very often. Okay, so when you have those instances, it's good to set up an index. Okay, so let's say we're querying type all the time, and type's just a constant query. So if that's the case, it's a good idea to set up a projection. I'm sorry, an index for that, not projection. So let's go ahead and let's create a type index. So we'll say db.cars.create index. Okay, and then we'll go ahead and say type equals 1. Okay, and that equals true. And as we can see, it successfully acknowledges that. So we go back to our database and refresh. Okay, and we can see now that we have the type index as well as the ID, right? So now we're going to perform even better now because we have that ordered copy and it doesn't have to look through the entire thing every time. Okay, so moving right along, let's talk about the concept of a one-to-many relationship within a database. So a good example of one-to-many relationship would be like Facebook. One user has many posts, right, that they're related to. Okay, and so another example, a little more visual, would be something like Yelp. Okay, so you go to yelp.com, and it tells you, a category and the places, right? So let's say we just want to find all restaurants near San Francisco. Okay, and as you can see, it has a one-to-many relationship there where it displays these many places based on this one restaurant's category. So let's go ahead and let's create a mini Yelp app inside our own database to where we are creating that relationship between our data. So to start, within our database, I'm going to create a couple new collections, okay? And the first collection is going to be called categories, okay? So that'll be like restaurants or entertainment, right? So the second collection is going to be called places, okay? Those are the places related to the category. So there'll be one category related to many places, okay? So we go ahead and we create that. Next, let's go ahead and insert some places, okay? So I'm going to go ahead and I'm going to say db.places.insert one, okay? And we're going to go ahead and we're going to insert a name and a type of place, okay? So we'll say the name of the place is Disneyland. Type, or not type, let's say category is entertainment. Okay, so now we refresh, we can see that we have one place, okay, and it's listing the category it's related to as well as its name. Let's go ahead and let's go back here. And let's add a couple more places. So we'll say db.places.insert one. We'll say the name for the place. We'll say it's Universal Studios. Oops, yeah, it did not like that. Hit enter a bit too early. Let's try that again. We'll say the name equals Universal Studios. And the category let's go ahead and make that equal to entertainment. Okay, close that up. Okay, that was successful. So we refresh. We can see now we have the 2 places. Okay, so let's go ahead and one more place, but let's make a different category than these 2 places. Okay, so I'm just going to say db.cars.insert 1. Then I'm going to go ahead and I'm going to insert a food place. Okay, so let's just go ahead and say the name of this place is In-N-Out Burger. Okay, and let's see here. The category, let's just say it's food. Okay, so we come back and now we have a couple different, how do you say it? Well, we should have a couple different places to work with. Let's try that again. It acknowledges true. So we could say db dot, oh, I said cars. I should say places. Insert 1. Name will be In-N-Out Burger. Okay. Category will equal food. Okay. So that looks like it went through a little more successfully. So let's go ahead and refresh here. Okay, so now we got 3 places. All right, we got 1 food place and 2 entertainment places. So now we can go ahead and we can add those to our categories. Okay, so I'm going to start off by saying db.categories dot well, let's see here. Yeah, we want to insert 1. Okay, so I'm just going to say the name of this category will be entertainment, and the oops. And the places associated with it. I'm going to go ahead and make an array of the IDs. Okay, so let's grab places here. Grab the ID from Disneyland. I'm going to pass that into this array here. And I'm going to do the same thing with Universal Studios. Okay. I'm going to close the array. Okay, now we got 1 category. And this category has all the different places that it belongs to. Okay. So from here, let's go ahead and add 1 more category for food. Okay, so we'll say db.categories dot create or insert 1. Name equals food. Category. Let's see here. Food. Oh, not category, places. There we go. So we only got 1 place so far. And as we can see, it is this one right here. Okay, so we'll go ahead and just pass in that ID. Okay. So from here, looks like it added that. So let's go into our database. We can see that we have 1 food category. Oh, I see. My collection's name. Categories. Yeah. Let's go ahead and get rid of that. Okay, there we go. Okay. So from here, now all we need to do is just like Yelp. We only have to make one single query and we can get many pieces of data related to one. Okay, so for example, if I wanted to find a food place, I could say db.places.find with a category of food. Okay, as you can see, it pulls out that place, right? You could do the same thing with the entertainment category, right? I could say find all places with a category equal to entertainment. Okay, and now, as you can see, I just get those. And everything happened in one single query. I don't have to, make two different queries, different collections. It's all related into one. Okay, so this is how we can create one-to-many relationship in MongoDB. So let's go ahead and let's open up the floor again, see if there's any last questions before we wrap up today. So floor is open. If you have questions, feel free to ask those now. Okay, it does not appear so. Well, if that's the case, thanks everyone again for coming. Have a great day and happy coding.